Okay, so what Stargazer then does is it prints this type of, so these are the item names, so agreeable, anxious, kind, tense. So the typical things you might have come across also with personality measures. You can see that we have 240 people. It seems that it's complete. There's no issues with missing data. You can see the means and the standard deviation, and you can see the minimum and the maximum. And that's the 1 to 9 type of range which they have. And we're going to treat that as linear. You can debate how linear that is, but 1 to 9 is better than 1 to 5 or 1 to 7 perhaps. So, but you can also see that sometimes none of the people use the lower end of outgoing, so that even you have some type of range restriction, even in a 1 to 9 type of scale. Okay, so that's just what the data looks like. It's also the type of thing you will be doing for your assignment, so making Stargazer type of tables. And by now it should sort of feel slightly familiar, hopefully. Let's go back to the slides. So measurement and sample sizes. So the sample size is sort of okay. We have 240 people. We have 1 to 9. We can always question how interval it can really be, but it's better than 1 to 7. It seems that there's some variation, so that we have people, sometimes it's 1 to 8, but 2 to 9, but it's not that it's all 1 to 4, for example. So I think that's quite useful. Now, multivariate normality. I had a look, and that's not looking great. So you should recall that we can test multivariate normality. For example, there are many ways to test it, but one of the ways to do that is this Mardia test, which I've shown you. So we call the MVN package. We ask for we asked to do the Mardia test, and here I said don't plot it because otherwise it wouldn't fit. So a QQ plot, but I'll show you the QQ plot on the next slide. But you can see there's evidence for skew and evidence for kurtosis. Gives a combined outcome that there's that the data are not multivariate normal. Yeah. You could say I don't trust any of those tests. Just show me the graph. You can see this is what is not going to make us super happy because ideally, as you might recall, on those QQ type of plots or on those type of plots, we want everything to be close to the line, and if they are diverging, that it should have sort of ideally we want it not to be always diverging to the same side, but to sort of swivel across the line. That's better than having them verge off into one way. Yeah. So there's some issues with multivariate normality, which I won't go into further, but things to keep in mind. Linearity, you can do pairwise scatter plots, but you can also, with a range of 1 to 9 is not very useful perhaps. I've done some here, but you can use GG plots again to, and I've just done this for the first 4 factors, for the first four items. So distant, talkative, correlate, hardworking, and then you can see the it will plot the correlations, which are too small for you to see here, but you should be able to see on your screen. And it will sort of show you the curves as well as so that's just how it's distributed, and it will show that's basically the scatter plot between those two variables. So you can get a quick overview. With 1 to 9, it's not very useful because you'll have lots of dots falling in the same place, but the correlations perhaps are useful to look at. I've just done it for, you can do it for all 32 items, but then you end up with such a massive thing. But we'll come to that. Basically, you want to also see some correlations there. So because if there's no correlations there, it doesn't necessarily matter if they're positive or negative. But if there's hardly any correlations above 0.4 or something, then you're going to have problems generating factor scores. So that's the purpose of doing this. Yeah. Factorability. And so in this case, you remember Bartlett's test, which we didn't want to be, so that's a test for sphericity. That's a test we didn't want to be significant, but here we want it to be significant because that means that there is meaningful correlations going on between those cases. So in this case, we want it to be significant and really highly significant because that would point that we can reduce some of the complexity. So Bartlett's test, bad for repeated measures ANOVA, good for factor analysis. And so that's the output which you will have also seen. And so you would do a sample write-up like this. You would say Bartlett's test for sphericity was significant, suggesting that factor analysis is appropriate. And so if it's not significant, then you run into problems and you have to see if you can perhaps reduce some items or if something has gone wrong in your measurements, but then perhaps you you're unable to factor analysis because there's no correlation going on. Now the final test I want to talk to you about before you do some things yourself is the Kamo test. The Kaiser-Meyer-Olkin factor test, so to speak, factor adequacy tests, and it will calculate a score for every single variable, and then that will basically tell you how factorable it is, like how useful it is to do factor analysis on this item. And we're looking, so it goes from 0 to 1, 0 really bad, 1 really good. We need the site package for that, and then just the command is kmo, and then just the data frame. Make sure also that the data frame only has the factors in, only has the variables in there which are going to use for the factor analysis. So this f_data has no other things in there except for people's scores, as you saw. Yeah. So if you have, let's say, gender or ID, then you have to remove those because otherwise it will be printed here as well, and it doesn't make sense to use your ID or gender variable. So most of the time you will have to make a reduced set to then use for your factor analysis. So we can see here that this is the average, so 0.84, so that's quite good, yeah. And you can then see for each single item how the scores are, so perhaps slightly less for, slightly not as good for agreeableness, but you can see that all of them are quite above 0.7, which is quite good. If you think of these as in terms of Cronbach's alphas or correlation coefficients, we would be quite happy with a correlation of 0.7 or in terms of effect or something like this. So it can go from 0 to 1, and we have agreeableness and perhaps laid back. They're not doing great in terms of factorability. Yeah. So how would you then write up these? Well, these are interpretations, and I love the terms. So this is middling, meritorious, marvelous. So you can label your items as being marvelous, to miserable. So that's the actual labels. You could say all my items were miserable, so we can't do factor analysis. And so if you would do a sample write-up, you would say all 32 items showed middling to meritorious adequacy for factor analysis, and then you would report all MSA large, or you could report the average, but I hear all of them were above this value. Yeah. So that's those are usually the steps people do before they embark on a factor analysis. And now I want you to try it yourself. So you can download the data from that link. The data are ratings from instructors by a study of by Sidanius. I want you to read in the data, and so this data is a full database. So you have to subset only the things which you're going to use for the factor analysis. We're only going to use a subset. So I want you to make a subset with items 13 to 24 inclusive, and you can use the dplyr package to do that, and you can use numRange to make your life easier, and otherwise you're going to have to do lots of typing. And I would like you to conduct the Kamo test. We're not going to do all the tests, but I would like you to conduct the Kamo test. Yes. So have a go at that. So you should be able to download the dataset from there. It's an SPSS dataset, as you might figure out. I'll just stop the video.